In this video, we're going to continue with limits at infinity and horizontal asymptotes with several more examples. So our first example in this video that we're going to do is the limit as x goes to infinity of 4x squared minus 1 all over 3x squared plus 2x minus 1. And so, as we had done in our previous video on this work, we want to take this kind of a function and we want to multiply by 1 over the highest power of the denominator. And we do that in the numerator and denominator. So this is 1 over x squared over 1 over x squared, and we want to multiply by that. Well, when we do that, this is the limit as x goes to infinity of, all right, this is 4x squared over x squared. That leaves us with 4 minus 1 over x squared all over 3 plus 2 over x minus 1 over x squared. All right, and then limit as x goes to infinity of 4 is 4. Limit as x goes to infinity of negative 1 over x squared, well, that goes to 0 all the time, so this is 0. Then we keep going. Limit as x goes to infinity of 3 is 3. These two terms will both approach 0. So we, in fact, get 4/3 here. And recall, right, if we're thinking about end behavior of a rational function, what is that? Well, you get a horizontal asymptote that is the ratio of the leading coefficients if your powers are the same in these rational functions. And you see that that is exactly what we got. Let's do several more examples in this video. The next one is the limit as x goes to infinity of 5x cubed plus 2x all over x plus 2. Again, we should multiply by the highest power in the denominator. 1 over the highest power in the denominator. So we do that. And we're going to get limit as x goes to infinity of 5x squared plus 2 all over 1 plus 2 over x. Now, here the denominator is 1 plus 0, so we get something that is approaching 1 in the denominator, and something that approaches infinity in the numerator. If we have something that goes off towards infinity over something that is a constant that goes towards a constant, then the whole thing goes towards infinity. So that was a pretty quick and simple example there. We have several more that we want to do, so let's keep going. Well, let's try example 3 here, where we take the limit as, let's use the variable t this time, just to change it up. T goes to infinity of t minus t root t all over 2t to the 3/2 plus t to the, actually just t minus 5. Let's just do that. Well, what is the highest power in the denominator? That is t to the 3/2. So let's multiply by 1 over t to the 3/2 all over 1 over t to the 3/2. So this is equal to the limit as t goes to infinity of t over t to the 3/2 is 1 over t to the 1/2 minus, well, t times root t is actually t to the 3/2. So this is t to the 3/2 over t to the 3/2, so just minus 1. 2 t to the 3/2 over t to the 3/2 is just 2. Plus 1 over t to the 1/2 minus 5 over t to the 3/2. All right, limit as t goes to infinity of 1 over t to the 1/2. Well, that's 0 minus 1 all over 2 plus this goes to 0 and this goes to 0. So plus 0 minus 0, this gives us negative 1 over 2, or in other words, negative 1/2. All right, let's try something slightly different here. Now, we essentially are going to multiply by 1 over the highest power in the denominator, but we have an x to the fourth plus 1 and then the square root of that. We can't actually take the square root of each of these things separately because we know that that's not how these exponents work. They cannot distribute across addition here. But what is this approximately? This is approximately at x squared, right? If we looked at what the highest power should be, it should be about the square root of x to the fourth. So what we're going to do is actually multiply by 1 over x squared again. So 1 over approximately the highest power in the denominator here. So let's see what happens when we do that. The x squared over x squared is just 1 in the numerator. But in the denominator, we can rewrite this, right? We want to move this inside the square root. So we're going to write it under a square root. But it can't just be x squared under a square root, right? Because that would be 1 over x. So this is really 1 over x to the fourth under that square root, right? If we take the square root of this, we get 1 over x squared. And let's go ahead and finish out this limit. There is something extra going on here when we do this step. We change the 1 over x squared to the 1 over x to the fourth. That will happen when this goes towards negative infinity. So you'll want to be careful of that. But a quick statement on that, right? If we take an x value, and this is positive, and we square it, and then take the square root, we end up with a positive. So this is all fine. If this happened to be a negative there, if x was going towards negative infinity, we would need to be a little bit careful, and that kind of depends on what our exponent is here and all of that, but we need to be a little bit more careful that we may need to introduce a negative. Again, not something you have to worry about in this particular problem, but that is something you should be aware of when you are doing this kind of a transformation here, from the 1 over x squared to the square root of 1 over x to the fourth. Be careful of negatives. Okay. So let's continue on. This is 1. And then now that we have a square root times a square root, we can just move this all inside. This is the square root of x to the fourth over x to the fourth plus 1 over x to the fourth. All right. And now this is limit as x goes to infinity of 1 over the square root of 1 plus 1 over x to the fourth. Well, limit as x goes to infinity of 1 is just 1. Limit as x goes to infinity of 1 over x to the fourth is 0. So this is the same as 1 over the square root of 1 plus 0, or in other words, 1. And that's where we'll end that particular example. We actually have 2 more examples I want to cover in this video that get a little bit more difficult. Well, one of them gets a little bit more difficult. So let's go ahead and cover those real quick. So this is example, what are we on? 3, 4, 5? We're on 5. So let's look at example 5 here, which is going to be the limit as x goes to infinity of the square root of 9x squared minus x minus 3x. All right, we want to solve this. Well, here we have something. We can't really see this yet. We'll see this in the next example of why this is the case. But this right here actually goes off towards positive infinity. And we take the square root of that, which still goes towards positive infinity, minus something that goes towards infinity. So this has the form infinity minus infinity up here. And infinity minus infinity does not equal 0. In fact, infinity minus infinity, we cannot say what that means. We need to do some work to figure out what's going on here. So let's change up this function And we're going to do that by multiplying by the conjugate. So we're going to multiply by the square root of 9x squared minus x plus 3x. And of course, we do that in the numerator and denominator. And so when we do that, the numerator is going to become, let's see, square root times square root is just what's left over. So 9x squared minus x. And then we get when we multiply by the conjugate, the middle terms are going to cancel. And then left over is a negative 3x times a positive 3x. So in other words, we get a negative 9x squared. And then the denominator is just as written. Okay, and now what do? Well, now this reduces to the previous problems. The highest power is roughly a 1 over x, roughly an x, and so we want to multiply by 1 over x in the numerator and denominator. So that's what we're going to do here. We're going to multiply by 1 over x over 1 over x. So this is really all equal to the limit as x goes to infinity of... let's see, negative x times 1 over x is negative 1. All over, now we need to distribute. This becomes the square root of 9x squared over x squared minus x over x squared plus 3x over x when we just distributed this to both things here. But when it gets distributed inside here, it's now a 1 over x squared because we moved it inside the square root, just like that previous problem. And so we get, let's see, this is negative 1 all over. This is the square root of 9x squared over x squared. That's just the square root of 9 there. So we get square root of 9 minus, this is 1 over x. Take the limit as x goes to infinity of 1 over x. That goes to 0. Plus 3x over 3. This is just plus 3. So we get negative 1 over 6. And that is it for that problem. Real quick, we'll talk about one last example here. And this one's a little easier. Limit as x goes to infinity of x squared minus x. Okay. Now note that we cannot do limit as x goes to infinity of x squared minus limit as x goes to infinity of x equal to infinity minus infinity, since these limits don't actually exist, since they go off to infinity and not some finite number L, so we can't actually separate the limit like this. Also, what does infinity minus infinity mean? Well, it doesn't really mean anything. Okay, so we can't do that. So how do we solve this one? Instead, we rewrite our limit as... Okay, so limit as x goes to infinity of x squared minus x. This is equal to the limit as x goes to infinity of, well, we can factor this. That is x times x minus 1. Well, what is that? That is the limit as x goes to infinity of x times the limit as x goes to infinity of x minus 1. And what do we see here? We see that these do a got something that goes off towards infinity times something that goes off towards infinity, so that goes off towards infinity. All right. Also, I should go back and reword something up here. Technically, we can rewrite it like this, but then we get infinity minus infinity, and this is the issue that we have. We don't know what that means. Okay? But yeah. All right. That is it. Yeah, but if we think about this, then we can see that this is easily something that goes towards positive infinity, because we get something that's infinity going towards infinity times something else that's going towards infinity, and so that should approach infinity. All right. That'll end it for this video.